Good afternoon, everyone. Today we are going to talk about mathematics behind linear regression. I am Prethiveerajan from Savita Engineering College from the Department of AIDS. What is regression? The main goal of regression is the construction of an efficient model to predict the dependent attributes from the bunch of attribute values. And regression problem is when the output variables either real or continuous value, that's salary, weight, etc. There are types of regression. The following are types of regression: simple linear regression, polynomial regression, support vector regression, decision tree regression, random forest regression. First, in regression, we will see about linear regression. Regression is a statistical term for describing the models that estimates the relationship among the variables. Linear regression models study the relationship between a single dependent variable y and one or more dependent variable x. If there is only one independent variable, it is called simple linear regression. If there is more than one independent variable, then it is called multiple linear regression. Here we see about the advantages and the disadvantages of linear regression. First, we will see about the advantages. Linear regressions performs exceptionally well for linearly separatable data. Easier to implement, interpret, and efficient to train. It handles overfitting pretty well using dimensional reduction techniques. One more advantage is extrapolation beyond a specific data set. Another one, disadvantages. The assumption of a linearity between the dependent and independent variable. It is quite prone to noise and overfitting. Linear regression is quite sensitive to outliers. It is prone to multi-collinearity. Let's consider a model with one independent future X and a sample training set where the dependent future is the size of the house. We will take it as X and the prediction of the house price be Y. As we know that Y is linearly, as we know that uh, in case of Y is linearly dependent on X, hence we can create a hypothesis that we all know that the equation of straight line Y is equal to mx plus c. To analyze the behavior of the formed hypothesis, assume that theta naught equal to 2 and theta 1 by equal to 5 by 8. Here, theta 1, theta naught, and theta 1 are called as regression coefficient. Basic algorithms to predict the values for all machine learning models is the same. From the training set, it will move towards learning algorithms. From the learning algorithms, it moves towards hypothesis. From the hypothesis, it is divided into target and future. The examples in daily life. Let us say you are looking to buy a new PC from an online store. You are more interested in and you see on the first page some PCs with 4 GB at $100. Then some with 16 GB at $1,000. Your budget is around $500. So you are estimated in your head that given price you saw so far, your PC with 8 GB RAM should be around $400. This will be fit on your budget. So you decided to buy one such PC with 8 GB RAM. This kind of estimations can happen almost automatically in your head without knowing it is called linear regression. So thank you.